Assalamu alaikum warahmatullahi wabarakatuh. Inshallah, my dear student, today inshallah we are going to talk about learning outcome 9. From in the Zomdali you will find it from the 10.3 of 20.1 till 10.3. Let's talk about the bonding in the solid. But before talking about the bonding in the solid, we are going to talk about the type of forces. Maybe when I have in the type of the forces called dipole. This is force is found inside the polar compound. Forces between and inside between molecules. Dipole can be classified as intramolecular, it means that the force between the atoms inside the molecule, like in the case of the water molecule, the attraction force between the oxygen and the hydrogen, since the oxygen have the partial negative charge and the hydrogen partial positive, the force or attraction between the oxygen and the hydrogen in this case is considered as dipole intramolecular forces inside the compound. But if we look to the forces or attraction force between the water molecule and another water molecule, the hydrogen bond, in this case called the intermolecular force. The difference between intra and intermolecular force, the intra greater than intermolecular force greater than intermolecular force. So we'll find the attraction is a single covalent bond between the oxygen and the hydrogen, more stronger than the hydrogen bond between the water molecule and another water molecule. Sometimes we'll find that another attraction force between the molecule it's called the London dispersion force. This is forces attractions found inside nonpolar compound, like methane, like hydrogen sulfide, or between noble gases as neon, helium. This is weak attraction force. So we are going to talk about the attraction inside liquid and the properties of liquid before talking about the solid. Liquids. We are going to characterize the liquid according to droplets shape, according to the shape inside the capillary tube, and the boiling point viscosity as the physical properties of the liquid. So firstly, let's talking about the droplets of liquid. We'll find the droplets are characterized by surface tension, and the attraction between the molecule to form drops of liquid. The drops of the water, like the drop of the water. Attraction between the molecule. we'll find the attraction between the molecule of the liquid is greater than the surface tension. Surface tensions mean the ability of the surface to penetrate it. You talk about the surface tension in the physics. Now we are going to talk about the shape in the capillary tube. Sometimes we will find the liquid like the water take concave shape in the capillary tube, like the water, concave surface. Sometimes we'll find like the mercury take the convex shape, maybe concave, maybe convex. It is related to the two forces called the adhesion or cohesion. Adhesion and cohesion. Adhesion, it's mean the attract to the surface, attraction to surface. Cohesion, it's mean attraction to each other. So, if we'll find the adhesion to the surface small and the cohesion between the molecules is high, it gives to us convex surface. Like in the case of the mercury, we'll find the adhesion to the surface, adhesion to the capillary tube is small, but the attractions between the molecule and each other of the mercury is greater, so it taking the convex shape. But if we will find the adhesion is high and else the cohesion is high, like in the case of the water molecule, so the droplets of the water, it's controlled by the two forces that try to attract it to another molecule beside it, and another force to attract it to the capillary tube wall. So we'll find it taking the concave surface. The second way for the comparing. The third one, we are going to talk about the boiling point of liquid. Boiling point is controlled by the molar mass of the compound. As molar masses increase, the boiling point increase. But sometimes we will find this for solutions like the ionic solution. Boiling point in the case of the ionic solution is controlled by the number of mole of ions. Boiling point depend on number of moles of ions. Like in the case in ACl, we'll find the water produce 2 moles of ions, one from the sodium and one from chlorine. 2 moles of ions. Okay, now we are going to talk about the bonding in the solid. Before we start to talk about the type of cubes of the solid crystals, we are going to talk about the shape of solid layers. We'll find the shape of solid layers may be hexagonal, closed baking, which called HCB, hexagonal closed baking. Maybe we'll find cubic closed packing. It's called the CCP, closed cubic closed packing. Maybe you will find the third type, it's called the cell unit. The cell unit, it means the crystals which have the cubic shape. The crystals is found in this center. It's called the cell unit, and we are going to talk about it in details, inshallah. The closed baking will find the crystal at the center and nearby the 2 atoms. This is called cubic closed baking. But in hexagonal, we'll find the atom surrounded by 6 atoms. This is called hexagonal closed baking. Now we are going to talk about the unit cell in details, inshallah, and we have the 3 types of the unit cells. Making pause to modify the pictures or the image size. Okay, now we are going to talk about basic introduction about the cell unit. The type of the cell unit, we are going to talk about the first type. It's called the number 1, simple cubic cell. For the cell unit in the simple cubic cell, like that shape, we are going to talk about it. What is the general properties of the simple cubic cell? Number 1 unit cell consists of 1 atom. If we look to this shape, we'll find it consists of only 1 atom. Why? Because each crystals or each part in this cube consists of 1/8 from the atom. يعني كل جزء من دول هو عبارة عن تمن من الأتوم. فهنا عندي 1/8 for each one. طبعا عندي كام 1 أو عندي كام بارت؟ 1 2 3 4 وفي 4 كمان تحتيهم، يبقى أنا بتكلم على 8. يبقى 1/8 تمن الذرة دي times 8 faces of the cube or 8 sides of the cubes, it's equal 1 atom per unit cell. Number 2, coordination number equal 6. What's meant by the coordination number? Coordination number, it's mean the atoms which attached to a single atom. The number of the atoms attached to each atoms. If we look to the simple cubic cells, we'll find this atom is surrounded or attached by the bond with 1, 2, 3, 4, 5, 6. So in the crystals, we'll find the atoms surrounded by 6 atoms. 1, 2, 3, 4, 5, and the 6. When we talk about the volume of the simple cubic cells, volume, we'll find the volume 52% atoms in the cell unit. The size of the atom or the space occupied by the atom in this crystals or the simple cubic cell, it will be 52, and we will find the 48 empty space. Okay, let's calculate it. Each side from the cube, this positions or this area to represent R, and else this is to represent R. To calculate the total 2 R's, it's called the edge length. Let's represent it by the X. X represent the 2R, it's mean the diameter of the side. Okay, so as we said, the edge length X represent the 2R. Let's calculate the volume. Volume of atom in unit cell divided the volume of the cube. We have only one atom, and the volume of the sphere atom, since the atom that have the spherical shape, volume of spherical atom this is divided to the volume of the cube. We know that the volume of the cube, length times width times height, and we'll find the each side represented by the X, so X times X times X, so it will be cubic X. So 1 atom times the volume of the spherical shape, 4/3 by R cubic, and you will have the cubic X or X cubic. So if we replacing the X by the 2R, so it will be 4/3 by R cubic, and the X is replaced by the 2R, so it will be 2R cubic. It gives to us 4/3 by r cubic divided 8r cubic. R cubic neglected with the r cubic, it will be equal 4 over 3 pi over 8. We calculate it, giving to us 0.5238, which represent 52%. So the crystal in the simple cubic cell, it's occupied 52%. Let's talk about the second type. Let's talk about the body centered cubic, represented by this shape. Okay, this consists of two atoms per unit cell. Let's count it. As I said before, it's aside from this represent 1/8 of the atoms. 1/8, 1/8, 1/8, 1/8, 1 over 8, 1 over 8, 1 over 8. So we have 1 over 8 times 8. 1, 2, 3, 4, 5, 6, 7, 8. And we have the complete atom in the center. So it will be 1 over 8 represent 1 plus 1. So it will be 2 atoms per unit cell. Okay, now we are going to talk about the coordination number. Coordinate atoms equal 8. If we look to these crystals, this is central atoms surrounded by 8 atoms. 1, 2, 3, 4, 5, 6, 7, 8. So the coordination atom or coordinate atoms equal 8. If we look to the volume, the volume of the atoms that occupy this body centered cube, BCC, body centered cube, it will be 68% volume of the atoms and 22% or 32% space. The edge live for these atoms, let's calculate it. Bismillah. If we're drawing the cube for these atoms, Bismillah. We will find that this side, the complete atom, and this side, each side represented by R, but this atom is completely represented by diameter. So the long diagonal for this atom represented by D equal R and the 2R. This is 2R, R and R equal 4R. So long diagonal of this atom أو this cell between bottom edge and top edge represent 4R. Take another diagonal, so this diagonal like that shape. Bismillah. Look to another diagonal. Drawing another cube. Talking about another diagonal, like this diagonal, this side represent x, this side represent x, and take this diagonal. This diagonal were represented the hypotenuse by the symbol by the m, and this x, let's, if you knowing that h live equal x, if you want to calculate m in this case, m square equal x square plus x square. This is equation number 1. Now this is equation number 2. Since in this shape we are going to talk about calculating the d, this x and this x, the right angle we'll find. In this case we'll find d squared, the long diagonal, this is called d, equal x square plus x square else. Let's talk about another shape. If we're drawing the another cube, Bismillah. And talk about the diagonal represent the long edge between the bottom edge and the top edge, which represent the d, and this diagonal which represent m, and this diagonal or edge side which represent x. So the d square in this case equal m square plus x square. This is 3. From 2 and 3, so we're removing the value of the m and represented x square plus x square. So we'll find d squared equal x square plus x square plus x square, replacing the m square by x square and x square. So we'll find that d squared equal 3x squared. In this case, if we're taking the square root in each side, square root d square equal square root of 3x square. Bismillah. We'll find that d equal the cubic root of 3 and x. If we said that the d represent 4r, as we said before, the long diagonal d equal 4r, so in this case the x will be equal r over cubic 3. So the edge side of the body centered cube equal 4r over root 3. Now we are going to talk about the volume, how to calculate the volume of these crystals. Bismillah. The volume of the body centered cube, from where we can calculating the volume. Bismillah. Volume of atom divided volume of cube. In body centered cube, when having the 2 atoms, so 2 atoms times the volume of the spherical shape for the atom, it will be 4 over 3 by r cubic, divided the volume of the cube, edge length times width times height, so length times width times height, so it will be x cubic. So 2 multiply over 4 over 3 by r cubic divided the value of the x, so it will be 4r divided the root 3 cubic. If we simplified it, we'll find it will be equal 0.680. Inshallah, this is the end of our session today. Inshallah, next time we are going to talk about the phased centered cube in next session. Inshallah, see you soon. Inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.